Okay, this is a solution to particle kinetics number 8. It's the one where a car is accelerating backwards at 4 meters per second squared, and there's a coffee cup that falls while the car is accelerating. Okay, so the car is going this way, let's say. We don't know how fast, it doesn't matter, but the velocity is to the right, and since it's slowing down, the acceleration then has to be to the left at 4 meters per second squared. And an object inside the car is in free fall. And it's just a bunch of questions about what would it look like to a camera that's mounted inside the car? What would it look like to a camera that's out on the street watching it happen? So the first question, A, is what's the acceleration? So the wording is, what's the acceleration of the coffee cup that's seen by an observer outside the car? So someone outside the car is, is on the ground, is in the ground coordinate system. You can think of that camera is mounted to the ground. So how are we going to get that? Well, here's what we have. Acceleration of the cup relative to the ground is equal to the acceleration of the cup relative to the car plus the acceleration of the car relative to the ground. Okay. Any object in free fall has an acceleration of 9.81 meters per second squared down relative to the ground. So this is 0, negative 9.81. This is what we're trying to calculate. And we know that the acceleration of the car relative to the ground is toward the left. So that's negative 4, 0. And now just do the algebra and you get that the acceleration of the cup. Oh, sorry, I'm getting ahead of myself. So the first one just asks, what's the acceleration of the cup relative to the ground? Well, we already answered that. Anything in free fall relative to the ground, the acceleration is 0, negative 9.81, or anyways, 9.81 down. I guess it doesn't have to be 0, negative 9.81, depending on what your coordinate system is, but we'll just use a regular one. So we'll use this coordinate system. Okay, so then now it'll ask some of these other questions. What acceleration would the coffee cup have to an observer inside the car? So that's the one I was thinking of. So we have acceleration of the cup relative to the ground is equal to acceleration of the cup relative to the car. That's what we're trying to find this time. Plus the acceleration of the car relative to the ground. Cup relative to the ground is 0, negative 9.81. This is what we're trying to find. This is negative 4, 0. Do the algebra, and you get that to a camera that's mounted inside the car, it looks like what the cup is doing is accelerating forward at 4 meters per second squared in addition to down at 9.81. And you know that experience from slamming on the brakes and everything looks like it flies forward in your car to you. That's because you're watching the motion of that object relative to the car. It's not really doing that, but that's what it looks like to you. Which of these coordinate systems is suitable for Newton's second law? Well, a coordinate system, a frame of reference can't be accelerating to use Newton's second law. So basically, you always have to use the ground coordinate system um, in order to use Newton's second law. If you're using the car as your coordinate system, your origin of your coordinate system is accelerating, and that means Newton's second law isn't going to hold. All right, so D, use Newton's second law to calculate the net force. Well, we know that, so we know that the acceleration in the ground coordinate system is 0, negative 9.81. F net is equal to the mass times the acceleration. So that's, you can think of that as 0, negative mg. Does it make sense that the force acting on this object in free fall is mg down? Yeah, that's what it means to be in free fall. That's always the force that gravity applies. Notice that if you use the acceleration measured in the car's reference frame, you'd have this positive 4, and then it wouldn't make any sense. There's no horizontal force acting on the coffee cup. It's just in free fall. So this one makes sense, but if you use Newton's second law with the acceleration of the cup relative to the car, it would not make sense. So that's the solution to particle kinetics number 8.